All right, let's talk about one more gauge. So this is actually the most common type of gauge that you'll probably interact with as an engineer. Not necessarily the most accurate, but usually the most common. So this is called a Bourdon gauge. And basically, it's what you think about as a normal gauge. Basically, the way that these things work is sort of sketched here on the bottom of this page. So what happens is you have a little tube here that goes to a coiled tube that sort of wraps around. And as it pressurizes or depressurizes, that tube tries to flex. As the tube tries to flex, it's connected via a mechanical linkage to a basically like a fixed post. And a set of gears will normally rotate a needle, and the needle goes from 0 to whatever your maximum range is. So that's basically how these things work. It has all the problems you would associate with a design like that. So in general, these things have to be calibrated at the, designed and calibrated for specific ranges. But that can actually be an advantage because you can actually tailor these to work at any range. And basically you can make them semi-accurate this way. There are versions of these where the needle is basically like that geared mechanism is actually sent to an encoder, and you can actually measure the position and digitize it. So there are various levels of sophistications of these gauges, but often the cheapest versions of these are as cheap as like $10. So they can be very, very cheap. Another thing that people often do to make these things a little bit more accurate. So one problem that these kind of gauges suffer from is that they tend to vibrate all over the place. If you have it's like I lost my thing. They tend to vibrate all over the place if the fluid itself has some vibrations in the line. But to get a more accurate average pressure, what people do is they typically fill the needle portion of the gauge with an oil that basically damps the movement of the needle, and that basically is what leads to more expensive versions of these gauges. One thing that I guess is not shown on this figure, but like the idea of that tube or that little coil expanding is true if it pressurizes, but it can also contract if it's under vacuum. And that means that some of these gauges actually allow the needle to go the other way and can measure both forward and backward, needle movements, in which case you can measure the pressure. They're not the most accurate vacuum gauges, but you can actually measure vacuum pressures that way. And like the cheaper versions of vacuum gauges are usually done that way, unless you need a high vacuum gauge.